Hello friends, welcome to my YouTube channel. Today in this video, I am going to discuss an interesting geometric problem and its application in the measurement of land. The geometric problem is very simple. We have a triangle ABC whose sides are small a, small b, small c, as you can see in the figure. If the side BA is extended by an amount d, small d, then what is the length of this dotted line from C to this capital D? Okay, I want the length of this dotted line. So, how to solve this problem? So, what we do? We drop two perpendiculars, one from A and one from D, to the base BC. So, A is perpendicular to BC, DF is also perpendicular to BC. Suppose this AH, now this is the altitude for this triangle, given triangle, and this DF is the altitude for this bigger triangle. So suppose this AE is equal to small h, DF is equal to small t, and suppose that this segment BE is equal to M and this segment EF is equal to small n. Then in that case, this segment FC becomes equal to A minus M minus N, because total length is A here. Now using Heron's formula for this triangle whose sides are known A, B, C. So Heron's formula gives area is equal to square root of S into S minus A into S minus B into S minus C. Suppose this is equal to delta, where S stands for semi-perimeter of the triangle ABC, which is given by A plus B plus C divided by 2. Sum of the lengths of the sides divided by 2. Area is also given by the formula half base into altitude, that means half of A into H. So half of A into H is equal to delta. So in that case H becomes equal to twice delta by A. So once ABC are known, delta is known and therefore H is also known. Now from this triangle ABE, this is a right angle triangle, so we can apply Pythagoras theorem to find the value of M in terms of C and H. So it is square root of C square minus H square. And now these two right angle triangles are similar. ABE and DBF are similar, therefore sides are proportional. So we get this equation. And from here one can easily compute the value of N to be this and T to be this. Finally, if we consider the bigger triangle, this DBC, triangle DFC, this right angle triangle DFC, if we consider, then the side T is known, A minus M minus N is known, therefore by Pythagoras theorem this will be known. So it is given by square root of A minus M minus N whole thing square plus T square. Okay, so this is, and of course if you express this M and T in terms of A, B, C and H, then it will look like this. A, B, C and delta, it will look like this. So this is the formula actually. Let us see how far this formula is correct. I have prepared a Excel calculator where I will put the value of A, B, C and this extended amount, and that should give me the length of the side, this side, what is that, CD. So here, so it is written solution, it should be CD. Okay, so CD equal to so in this triangle, now how much is small a? Small a is BC. Now let us calculate it accurately as far as possible, not accurately, but let's see. First of all, let us use the grid line. So this is a centimeter grid, and now I use this ruler. And if you see in the centimeter grid, if I put this ruler, uh, this 3 marks equal to 1 centimeter. Okay, 3 marks equal to 1 centimeter. So this one, this is already here. It is from one corner of the box to another corner. So this is how much? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 16 centimeter. So let us put here 16. Then B equal to. So B equal to, again I put it here like this, and then how many? 10, 20, 30, 40, 45. So it is 45 divided by 3 is 15. So it is 15 centimeter. So B length is 15. And this one, last one is, I want this length. So this length is how much? Yeah. So this length is 10, 20, around 21 approximately. Okay. 21 means 7. So I put 7 here, and then this length is how much? Around 9. Okay. 9 marks, so it is 3. So it is 9 marks means 3. So moment I write 3, CD length it is giving 15.5. Let us see what is the CD length here. This is CD. Let us see this one. CD. So it is here. Okay. Okay. So it is how much? So 10, 20, 30, 40, 45, little more than 45. Okay, as you can see, slightly more than 45. So it is slightly more than 15. Okay, yeah, slightly more than 40. So it is slightly more than 15. 45 slightly more than 15. And what is the answer given here? 15.55. So quite close. This scale measurement is not so accurate. Little bit of error is of course there, but it's quite near. Okay, so you can see 10, 20, 30, 40, slightly more than 45. So that means slightly more than 15. So our answer is also slightly, in fact, 15.5. So quite close. All right. Now, this particular okay. Now, this particular formula, now you may have a different type of triangle also, where this angle is obtuse or this angle is too small, and this C is quite much bigger than B. Then what happens? So if the triangle is obtuse, then the altitudes fall on the left side of the triangle, both the altitudes. And therefore, as you can check, the formula for this CD will be A plus M plus N, this part, FC. FC is that part. So it is A plus M minus M plus N. So another case is, and in fact, this is the only case where the formula is different. Another case is this one. Okay, this side is bigger than this side. In that case, altitude of the triangle falls here, but this altitude is outside on the right. So here also FC is this one. This will be M plus N. Okay, minus A. So it is M plus N minus A, but it is because it is inside square, so it is same as A minus M minus N. So this formula is same as our previous formula, this one. So this is one situation. Another situation is that both the altitudes are falling on the right. In that case also, FC is this one, A is this one, and BE is M and EF is N. So it is M plus N minus A. So again this formula is this, but because it is inside square, so it is same as A minus M minus N. So this formula also same. So only this obtuse angle here formula will be different. Now let us see as an application. Let us try to see this situation, this problem. Now here I have a land. It's a quadrilateral whose all the four sides are different, or sides are of different length, and there is a house built inside it. Question is, what is the area of this quadrilateral where the sides are known? Now, if this house were not there, then we could have measured one of the diagonals and then use Heron's formula to find the area of this quadrilateral. But since there is a house here, we cannot use a measuring tape to measure this diagonal from A to C. We cannot do that because there is an obstruction of this house. Or B and D also we cannot measure. Distance between B and D also we cannot measure because of the presence of this house. Now, how will you calculate the area when it is a occupied land? It is not vacant land. So, idea is that we choose one of the corners in the boundary. Okay, preferably choose that corner which has got sufficient amount of empty space around that corner. So, for example, we choose this corner B, and also we first preference will be to choose such corner where the angle is acute angle, so that we can use our first formula today. Okay, but if it is a obtuse angle, for example, if this corner you choose, then you cannot use this formula. You have to use the obtuse angle formula, this one. Okay, so let us use this one. This is acute angle. So what we do after choosing this B, we choose 2 points E and F on these 2 lines. So this corner we have chosen. So this angle is made by 2 lines AB and BC. So on these 2 lines we choose 2 points so far away from B that the line joining E and F doesn't touch the building, or the building doesn't come on the way of E and F. You can see F from E and E from F. In other words, you can measure the distance between E and F using a measuring tape. Okay, so push this point E sufficiently away and this also sufficiently away. So both this part and this part should be sufficiently big. Okay. we could have taken E to be equal to A, but in that case, F will come this side, so this part will be smaller. So this is a optimal situation where both these sides are simultaneously large enough. Okay. So such a corner you choose and you mark this one as E and this one is F, and using measuring tape we measure the distance between B and E also. Suppose it is 6. We measure the distance between E and F, suppose it is 7, and measure the distance between B and F, suppose it is 5. Original sides of the length are this is 10 units, 16 units, 14 units, 15 units. Okay. So this way we do. And now we do what? We concentrate on this particular triangle. Okay. Then this C point is something like as if BF has been extended to C. So therefore, by our geometric problem, we can compute the distance between E and C. Okay. So our situation is like this. We have chosen 2 points E and okay. What is the 758? Sorry, these numbers are different. Suppose this is 7. This is 8. Okay. In fact, we have written these numbers using our scale. I show you how we have done it. So we put the grid line first and then we take our ruler. So you can see here, let me rotate it. Yeah. Yeah. So you can see here, I put it upside. Okay. So you can see here, this is, if I put it, then this is 10, 15. So this is actually 16 mark. So 16 mark means 16, and this one is 10, 20, 30, 40, 45, 46, 47, 48. So this is 48 mark and this is 16 mark. So 16 is approximately 5 divided by 3 and 48 is approximately 16, accurately actually 16. 48 divided by 3 is 16. So that's correct. And even the other one, this one, okay, before since it is already tilted here, this one is from E to F. So this one is 10, 20, 24. You see 24 mark. So that is 8. Okay. 3 8s are 24. And this one is here, this side I put. This is the beginning. Yeah. Yeah. So it is 10, 20, 30. 30 means 10. So it is 10 units. And this one is 10, 20 approximately. Okay. 20. Okay. 20. Or maybe, yeah. 20. 20 is nearly 7. Okay. 3 7s are 21. So that's nearly 7. And 30 means nearly 10. So in this others are also measured like this only. Since I am showing, let me show you all of them maybe. So this one is 10, 20, 30, 40. Oh, sorry. 10, 20, 30, 40 and 44 maybe. This one is 40, yeah, 44. Little more than 44. So that is approximately 15. And this one is approximately how much? This one is approximately, if you see, 10, 20, 30, 41, approximately 41. So that is 14. 3 40 is 42. Okay, so that is how this is there. Initially I said suppose these are 7, 8, 5. No, these are actually 7, 8, 5. If you take these sides as 10, 15, 14, 16 and all. Okay, actually means up to little bit of approximation. Okay, so I corrected here, but I forgot to correct in the earlier place. Correct them. And this is, let me cross check once again, 10, 14, 15, 16, okay, 10, 14, 15, yeah, the rest is correct. So, okay, so from considering this triangle, first we calculate this distance EC, and then again consider this bigger triangle to calculate the distance, and this A is as if BE is extended to this, so we can calculate the diagonal also. After that we will use the Heron's formula. So we have to calculate the distance between E and C, and then we will calculate the distance between A and C, and then we will calculate the area. Okay, so only this length you have to measure using measuring tape, and this length you have to measure using measuring tape, and this also using measuring tape. Building is not coming disturbing us when we are trying to measure these lengths, but we cannot measure the diagonals and all. Okay, so we used our geometric problem for this triangle. So here you see, if you consider, look at this line is extended, that means C line is extended and opposite one is A. So C line is extended, opposite one is A, and the remaining side is B. So this method we have to use here. So where is the situation? Yeah, yeah. So first of all, this one. So this line has been extended, and so this line is C. So C equal to 5 and A equal to 7. So again I go back to my calculator. C is equal to 5, A equal to 7. This is the one. C equal to 5, A equal to 7, and the other one is 8. Other one is 8, and D part is the extended part. That means this one, 16 minus 5 is 11. So this part is 11. Okay. So we see it is 16.52. So 16.52. EC is 16.52. So this EC becomes 16.52. 16.52. Okay. Let us see our grid line, and we go to our roller. Okay. So already know that this one, 3, how many 3 marks are there? So we put, okay, not this one, C, E and C. So not that one, E and C. So let us put it here. Okay. A little bit more. Yeah. Yeah, that will do approximately. So 10, 20, 30, 40, 40, 50, less than 50 in fact. So, somewhere around 49 or something like that. So if you divide by 49 by little more than 49, okay, as you can see, 49 by 3, how much you get? You get actually 48 and 14, yeah, nearly a little more than 16. So this is correct. Okay. Okay, three times this is your 49.5 or something like that. So here also you can see it is something 49.5 only. Okay. So it is quite accurate. Okay. So this is correct. So 16.5. Now I close this ruler. Okay. And now we consider now EBC. And now this we have to measure. So A is extended. So this is now our C. C becomes now 7 and opposite side is this. A is 16. So 16, A is 16, C is 7. So A is 16, C is 7 and the other line B becomes that new line 16.52. 16.52. And how much you get here? This also is coming 16.52. Is it correct? No. Where did I go wrong? Oh, sorry. This one is, I think something is missing. Oh, D I have not written. Sorry. D I have not written. How much is D? D means this extended part. So total is 10 and this is 7. So 10 minus 7 is 3. So this is vacant. Here I have to write 3. So if I write 3, yeah. So now the answer is 17.61. So this one is AC is 17.61. So here I write 17.61. 17.61. And let us again see our ruler, what it does. How much I get here? Yeah. Sorry. Yeah. So if I put it one bigger line here, yeah. Then how much? 10, 20, 30, 40, 50, and then 1 mark, 2 mark, 3 mark. So 53. 53. So 53 means how much? 3, if you divide by 3, 3 17s are 51, then 2, and if you divide by 2 by 3, it is 0.66, and it is, if you can see, it is slightly, okay. So 17.66, and here the answer we are getting 17.61, and scale says 17.66. It's quite accurate, okay. So that means it is giving an accurate result. So I forget the ruler now. So this calculation is correct. So this is 17.61. And now once we know the diagonal, even though the building is present, without using a measuring tape, we have calculated the distance between A and C. That is one of the diagonals. And then area also, this Excel calculator calculates the area also. It is 180.5. So 180.5. Okay, using Heron's formula. This is one part, this is another part. So Heron's 180.5. So this is 180.5. So that is how you can calculate the let. So hope you have enjoyed the video, and thanks for watching.